Hello everybody, my name is Eric, and today I'm going to show you guys how to do beautiful simulations in OpenFoam and simulate something like this front wing from the Williams car just a few years ago. This simulation is done in a program called OpenFoam, and the data is visualized using ParaView. I'm going to show you how to do this from basically scratch so that anyone can do it, and yeah, let's just get right into it. So as you can see on the left, I'm actually running Linux. Linux in principle is not completely required, but I would really strongly recommend it. Um, yeah, so definitely probably install Linux. I have my Linux on a separate hard drive and it works pretty well. I'm not going to go over how to install Linux in this part. If there's enough demand, I'll make another part on showing how to install Linux, but I think there's also a lot of good guides out already. I just followed the website, so you can probably do the same. I'll have that link below, and it's quite an easy install. In this part, I'll also not be assuming any Linux knowledge, so just basic, yeah, nothing. And then in this video, I'm going to show you guys how to install OpenFoam, and then also understand the basics of OpenFoam and what it is. Before I do that, I also want to say some system requirements so that no one wastes a ton of their time. You do need a somewhat beefy computer. So I have a Ryzen 2600X in here, which is not super high, don't get me wrong, but it is something. It's 6 cores, 12 threads, and then for memory I have 16 gigabytes, and as you can see I'm using almost the entirety of that, so I would really recommend at least 16 gigs. You could probably get away with 8 gigs if you only simulated half the wing, so right now I'm actually simulating the whole wing. But if you wanted to, you could only simulate half. It's also possible. You might be able to get away with 8 gigs. As for if you had a lower CPU, you can get away with technically almost anything, but it will just take you longer. And as for reference, running time for me took 20 minutes, including the decomposition. So, yeah, adjust accordingly. Of course, if you simulate half the domain, it will probably take about half the time. So, yeah, let's just get started then. I'll first show you just a bit about the simulation, just to show you the power of it. So I have this wing, and in the red you can see the pressure. So red is high pressure, blue is low pressure. So you can see a lot of high pressure here, but then if we flip over, then it's actually much lighter here, showing that there's low pressure, so it's sucking the wing down, as you would expect. On the stream tracers you can see the velocity. So the velocity in the blue, so from blue is 20 and red is 40 meters per second. And you can see that it does speed up a little bit here, but yeah. You can also see like how the air goes upwards. So I can actually turn the wing off, and then you can see that it really goes from flat to up, and that's sort of what also gives it some downforce and drag. Yeah, so this is sort of the stuff you can get. You can also simulate anything from the car. So let's delete some of these, free up some memory, and then I'll show you some other stuff that you can simulate that's all included. And what I'll do is I'll just quit this, so this will be faster. Don't worry about what I'm typing in now. I'll tell you all of it later. But all of this data came from a leak of the Williams car from a few years back. So in principle there's a lot. So you can download this file. I'll have it linked in the description, and I'll probably show it in a second. But let's say if you want to simulate the barge boards, we can open the barge boards, and you can see if you're interested in the barge boards of those years, you can also simulate that. Or probably the most interesting is the turning vanes, SIS vanes, and these are extremely complicated aero devices that sit on top of the barge boards. This will also be super interesting to simulate. You see the left one there and the right one here. This is only half the car, but these will also be super interesting to simulate, and you can simulate whatever you want, because I'm going to give you the tools on how to simulate it rather than just being a complete step-by-step guide. Okay, so with that, let's get started. We'll close out this, we'll minimize this, and we will go to Firefox. Luckily, Linux comes with Firefox installed, so it shouldn't be a big problem. I'm also gonna say right now I'm no CFD master. I'm just a guy who did a few courses on it and can use Google basically. So this is what OpenFoam is. It's this CFD program where you can model stuff. So here they're simulating an elephant, but also you can use it for automotive. And this is all command line. So this is technically not OpenFoam. This is the visualization of OpenFoam results. So that's fine. But yeah, so first things first is to install OpenFoam. So we can do that with this link. I'll have this link in the description, and we're basically just going to follow this, and I'll walk you along and make sure you don't get lost. So the first thing is to run these two commands. I'm not really 100% sure what these commands do, but I'm pretty sure that they're just making sure that your Linux knows where to get OpenFoam from. So we're simply just going to copy this and paste it into our terminal. Your terminal you can most of the time find on the left side. If it's not there, then you can go to the bottom left and it's show applications, and then look for terminal wherever it is. It's kind of an alphabetical order sometimes. I guess mine is already here, so it's not going to show up. But yeah, so open the terminal, and then simply just Control C from here. The one thing is that when you try to paste in the command line, if you do Control V, it won't work. That's because Control C is normally reserved for canceling a program. So what you can do is do Control Shift V, and then it will paste. I don't know what everything here does, but this sudo means super user do. So it's just like doing this with admin rights. And then just paste this. If this command doesn't work or something, then you can try removing the S in HTTPS, and it might work, maybe, but after you do that, it should probably work. Okay, I think I've already done this, so it goes pretty quickly. We'll do the same thing for the next one. This is really adding the repo, so I don't really know what the first one was doing. But okay, this one has no S, so should be fine out of the gate. Press enter to continue. Yeah, just continue. This 404 error, I've got it both times. I don't really know what it means. I just kind of ignore it. Then this one is just to simply refresh it with the new repository location. So we basically said, hey, you can look at this location when you need to get something. And now we're saying you can always get there. I don't know. And now finally, this is the big one, is sudo superuser do apt get, so package manager get, and I want you to install OpenFoam 10. Version 10 is the version we're on. Perfect. So press enter to send the command, and then it will install it for us. And you can see yours should come up with this. To use OpenFoam, please add this to your bash RC. So this is something that did puzzle me for a second. I didn't fully understand it. But basically, when you run, let's say, OpenFoam, and then I type run OpenFoam into my command line, how does it know what I actually want it to do? And the way to do that is that you need to go into your bash RC folder or text document and tell it that's what you want it to do. But where is it? Great question. So it wants it to add this, so let's just copy this for now. Again, you have to do Control Shift C to grab it. And it doesn't really tell you where it's at. It's kind of a tricky one. I ended up looking it up. And it's just actually in your home directory. So what is your home directory? Great question. Well, first off, you can find your home directory most of the time by just going here. Then it's here. But it's also where you boot in with your command line. So if you haven't changed anything anywhere, you should actually be there. Now, I actually have been moving things around. So in any case, we'll do the for sure version, and also teach you a bit of Linux on the way. CD means change directory. We're going to type that in. and then you can do slash. So then you will change directory back to your slash directory, and this is, I think it's called your root. But then you're really at home. Like, you can do this anywhere, and you do cd slash, it'll always bring you back to this point. So it's like always teleporting back here. Next one up is ls. I think it means a list. But then you can list the folders, files in this directory. Great. So those are your two most common, cd and ls. So in order to get to your home folder, you simply need to do cd home. And then you should also change to your own file. Or do you? I think, let me check. We'll see in a second. Of course, if I do ls, I haven't seen it in either place, right? So I went, I did ls when I was in home and it wasn't there, and I did ls when I was here, also wasn't there. So what you need to do is ls-la, and this sort of shows some hidden files, I believe. So we'll do ls-la, and then here we can see, oh, bash rc, there it is. I don't really know why it's hidden. I guess they don't want you to edit it, but we're going to do it anyway. So how do we edit it? Well, basically what you do is you do nano. So nano is, you can think of it like a text editor, basically is, but it's in the command line. And then our folder name or file name, bash rc. And this will basically open anything as if it was a text document. So we'll see what happens when we run it. Okay, we have something that looks like text, or at least it's in English, so that's a great start. And all we're going to do is we're just going to go down to the bottom, and we're going to see here source opt/openfoam/etc bash rc. So this is now telling us, like, okay, you need to use the OpenFoam folder we just got. I think if you copied it, then you should be able to paste it and then just replace this dot with source. Then to save what we just did, it's most of the time doing Control O to write out. So if you ever get lost, you can always look on the bottom and see all the commands. But most commonly is Control O. I think the up caret means O. So Control O, file name to write. We still want the same file name, so I'm not going to change anything. Just press Enter. So now we've written our file, so we're good. Now we just need to leave Control X. So once again, Control O, Enter, Control X to exit. Perfect. So now we've added that, and we can do a small test to see if this actually works. I actually think it won't work. If I do parafoam, maybe it works because I've already fixed it, but parafoam was the program I was using earlier to visualize our results. So if I press parafoam and then enter, and then press yes, don't worry about it, then something should show up. If this doesn't show up for you, I think it probably won't. Then simply close the terminal out and reopen it, because it kind of needs to refresh the bash folder we just did, because it needed to load the file. So I would recommend, I think for most of you guys that won't work, do close it, reopen it, then do parafoam, enter. It's going to give you these warnings, don't worry about it. And then it works. I mean, we have an empty box, but this is a great start. Yep, so next we're going to be going into a lot of files and folders. So I'm going to open up this file folder also for reference so you guys don't get lost. But in principle, it's not strictly needed. You should become very comfortable with the command line, as it will make everything go a lot faster. So what's useful to know is that OpenFoam comes with a lot of tutorials. And these tutorials can be really useful for getting you a good working starting base point. You just need to find a tutorial that's similar to what you have. So we have a front wing, so we're going to try to take a tutorial or a simulation that's similar to ours. So in order to that, we need to go to the tutorials folder. Now when OpenFoam was installed, they installed a global variable that always allows us to teleport to their home place. So we get to that by doing change directory. We we index variables with a $sign sometimes, and then in all caps foam underscore tutorials. You can also press tab to autocomplete something, so I just type tut and then press tab to complete it. Okay, then we'll end up in the tutorials. And you can see where we're on opt OpenFoam tutorials. So I'll also go here. Yeah, opt OpenFoam 10 tutorials. So this is where we're at. We can press LS, and here you can see that the same thing is here. So these all clean, all run, all test. 1, 2, 3, they're all there. And then all these other files, mesh, let's say, is right there. So I happen to know where a good thing already is, and it's going to be in incompressible, and then in simple foam, I believe. So once again, we're doing the same thing, but in the command line. Simple foam, or sorry, incompressible, and then simple foam. All these have different things. I could spend there's probably videos already telling you what they are, but simple foam is what we need. And then we have these cases. So airfoil, probably not a bad one to take, but I didn't take it. Motorbike, that's what we're going to use. And then all these other ones. I think I tried wind around buildings, but that's a bad one. Okay, so motorbike, that's the one we want. Yeah, we're now just going to simply copy this motorbike file. Let's go in it first. We're inside of it, and here we can see what's actually inside. I'll talk a bit more about this, but this is basically the bones of a OpenFoam case. So we will go up. You do that with cd ... and a slash also, it's not required. But then you go up. So then we go from simple foam, we go up a level. So that's also really useful for navigating up and down trees. Okay, so we're going to copy something. We do that with cp -r. -r is recursive, so it will go and copy including the folders, which is useful. So yeah, take that. Then we have to specify what we want copied. We want the motorbike one, so I just did mo tab. And then we got to decide where we want it to go. And let's say we're going to probably put it in the documents. That's where I put all mine. As you can see here, I have some files and an F1 wing. So that's great. We're going to also put this right here. So best way to do this is cd slash, not cd, sorry, just slash. And then we'll do home, Eric, that's my name. And then documents. Yeah. Also, if you ever get lost, so let's say I knew that documents was next, but you probably didn't. So what we can do is just double tap tab, and then all the options will show up. So it's kind of like doing ls in that way, that you can see what's there. And then see, okay, Eric slash documents. Okay, that's what I want. doc, and then you have documents. And I could do it again to see, oh, F1 wing, well, we're there. You could also make a directory, but right now we'll just throw it in there. Okay, and there it is. So let's actually go there. cd slash home, Eric, documents, and now we're there. And maybe it's a bit nicer that this is one case, but we could run many simulations. Maybe we want to do the front wing, the rear wing. So let's make a folder, and we'll call it F1 simulations. So you can make a folder with mkdir, make directory, and then we will now make a directory and we'll call it F1. Maybe do something else. I'll just do simulations. I do this simulations. I do this because I was going to call it F1 simulations, but then I have to do F1 each time. So yeah, so it's going to make a directory. We have that there. And then we can move mv /r or -r for recursive to include the folders. And then we'll move the motorbike into the simulations folder. Oh, you don't need -r for move. I forgot. Oh, lovely. And then as you can see, now it's inside there. Yeah. Okay, so now I want to show you what is in an OpenFoam case. So I'm going to do this on the right and the left just so you can see. So we'll go into the motorbike folder, and there we can see there are 3 folders and 2 things, files, I guess. So let's start with the general idea about this. So this 0 folder, that's the time step. So we're saying at time equals 0, we wanted to have these properties. This velocity, this pressure, this everything. And we can see that if we go into the 0 folder, then we see all these. So it says K, nut, omega. Yeah, don't know what those are really, to be honest. But P is pressure. And U is velocity. And dot orig is original. Okay, pressure. You can see that it has these. This is like an information file in OpenFoam. It has C++ formatting, so if you've used that language, you can maybe notice the commenting style. You can also open that in the command line, again by using nano, and then opening P. As you can see, we have the same file here. Don't try to save them at the same time, you will screw up your computer. So, starting from the top here, we have dimensions. I forget exactly what it is, but these are all units. So, I guess this is, I don't remember. I think this is maybe meters, kilograms, and second. So the base SI unit of Pascal, I believe, is meter squared per second squared, maybe. But in shorthand, Pascal. Oh, so this is just saying the units, and this is sort of a check or something. I don't know. And then it says a lot of things. I'll go through it quickly, but if you don't understand, it's also not super important. Basically, we're saying that the internal field is going to be all uniform, and it's going to be at the variable pressure. Where this variable pressure comes from, it comes from this initial conditions, which is a different file. Then we have our boundary conditions. So we have 6 walls, and what are each of them going to be? You have the inlet, so 0 gradient, yeah, I guess. Outlet is going to be a fixed value, and that's going to be equal to the internal field. Again, another one that's sort of weird, but this is basically saying that the pressure at the front will increase and the pressure at the outlet will always be the same. That's fine. Lower wall, 0 gradient means that it's sort of just continuing the simulation on. And motor by group, yeah, there's also something, but it doesn't matter. Basically saying that the bike will push back as hard on the pressure as the air will. But don't worry about that too much if you don't understand it. Then we'll also look at nano U just for fun. So here you can see meter per second, so I was indeed correct. Internal field is going to be the flow velocity, which is, again, in this initial conditions. Another thing is that scroll wheel kind of works on this, but it, of course, is still command line, so you can just see I'm just moving the cursor. But if I try to use the cursor here, like, it won't really work. Okay. Outlet is going to be a uniform outlet. Lower wall, fixed value. And then no slip is kind of interesting here. If you have done any fluid dynamic courses, you know that actually fluids sometimes don't slip over solids. So that's the boundary condition they have here. You can change it if you want. I wouldn't recommend it, but you can do whatever you want here. Okay, so that's the 0 folder. 1 out of 3 done. We will go back up and go to the consoles folder. It's probably one of the easier folders. You have these things. So the geometry folder is where it has a readme in it now, which is not super useful. But this is where you'll paste the OBJ file, the object file that you get from, let's say, the Reddit download or whatever else you want to make. So you just throw that in here. Momentum transport. These are not super relevant, to be honest. They have words, but I don't know what they mean. Yeah, viscosity model and this. Unless you know what you're doing, don't touch it. I know a little bit know what I'm doing, and I still don't touch it. These are, yeah, something, but don't worry about it. Sorry, it's not really helpful. But what is useful is this geometry folder. You're going to paste your geometry in here, and we'll use that later. System. System folder is probably the most complex, but also the one you'll be spending the most time in. Some of these don't matter, so I'm only going to go over the ones that do. Block mesh dict does. So for these simulations, they are all gridded. If that makes any sense. Maybe I can find one. Here you see these planes, and they're all grids. I showed you even my simulation before. It didn't look like a grid, but it was. It's just the grid is very, very small. So you need to make a grid. And what they're doing is they say, okay, vertices, Well, our vertices for the motorcycle case was -5 meter, -4 meter, 0, and these are all just vertices on the geometry. I'll tell you all these later. Don't worry about it now. Blocks. This is saying how it's defined. Again, don't worry about it. We're not going to change this. Boundary conditions. We saw that the inlet was something, but how do you know which face is the inlet? Well, that's defined here. So here we say 0473. That means that the 0th one, the 4th one, the 7th one, and the 3rd one, this will make up the inlet. So you can draw a square on those, and that should be the inlet. And then it makes a little cube. But of course, we don't want a cube. We want a F1 wing, basically. So the way that OpenFoam does this is it takes the mesh and it combines it with the OBJ file and rams them together, and wherever the overlap is, then it makes it more fine, basically. And that is done in a process called snappy hex meshing, I guess. This has a lot of stuff. It's 200 something lines. Luckily, it's quite well commented, so you can read it if you want. A lot of this stuff I don't know because this is not really my specialties. I never made my own meshes, to be honest. So all that we're going to do is later on we're going to go through and we're going to change these OBJ files to our OBJ file, basically. Or we could even just rename our OBJ file motorbike, and then we don't have to do anything. However, we will need to change this refinement box, so it needs to at least look in the right box. And then one other thing we're going to need to do is this point. So it needs to know what is inside and what is outside of the wing. So this is quite important to also change. A lot of these can also make your meshing faster, but at a cost of also making the mesh worse. So it's a very fine balance of what to change. I will kind of just tell you some good settings for the wing. Otherwise than that, it's just trial and error. Some other stuff. Control dict. This is the settings of the simulation. So it's telling we're going to use simple foam. We're going to start at time equals 0. We're going to end at 500, which we're going to change later. And some other stuff. Not super important, but it is like the bare bones. This is the first thing that gets run. And we'll do one more, and then we'll move on. Is this decompose paradict. And this is for multi-threading. So by default, OpenFoam runs in a single thread. However, we will want it to be multi-threaded. This is highly dependent on your CPU. So if you're on Windows, you can check it by simply going to Task Manager, and then you can see how many threads you have here. This will pretty much always list the threads, not the CPU cores. And most of the time we're interested in the threads anyway, so that's fine. So that's where you can find that. And that should roughly correlate with how many threads you use. I would really never recommend using all your threads either, because you'll kind of hurt yourself then. But yeah, that should be like, I have 12 threads, I use 10 for simulation, and it works out pretty well. Like my computer is usable, but not really when I do that. I just kind of go on my phone or something. And if you multiply these three together, it should end up on this number. Yes. Okay. Well, I think I have one more thing. The all run file. All clean file, don't worry about it. If you ever want to look at this file, you need to do /dot. Am I in the right space? No, I'm not. Nano -dot all run. You need to do -dot or /. All run. Alright. Oh, I have cap locks on. I think you can also probably do it like this. Yeah, you can. This is actually kind of showing you what OpenFoam runs when you do it. So in principle, what we could do right now, and maybe I'll do it, is you could just simply go, what is it just all run? I don't really know. There's some prefix, but if you just run this all run file, then it will actually run it for you, and you want to touch anything. So you could simulate a motorcycle in the wind right now just by running this command. I'll look up the command and we can run it together. Okay, but what it does is it says, okay, we're going to run from this directory, obviously. It's going to then copy the motorbike surface. So as I told you, the geometry folder was empty. It needs to grab the geometry. We're going to put our own geometry in there. It will run the surface features. That's basically turning this OBJ file into a different sort of file that's more on edges, not super relevant. Block mesh, that was what I was telling you about, making that basically our domain, our hexagon, a rectangular domain. Then it's going to decompose. That's going to be separating it from one core to 6 threads. Copy 0, some argument we throw in there. Snappy hex mesh, that's going to be throwing our mesh and our server feature files. We're going to be throwing them together and looking at the intersections and solving that. Then, just summarizing the patches, we'll run something else quickly called potential foam. Does something you don't really know. Run parallel get application. This is simply just running simple foam. Simple foam is the simulation basically. Yeah, it's a simulation that solves the CFD, and it will basically just say where's the flow going and what's going to happen. Basically, this is the simulation, and then it will reconstruct everything from 6 cores down to 1, and then it will, it will reconstruct the mesh, and then reconstruct the results. And then the simulation will be done. So let's actually go ahead, let me look up that name, and then let's run it and just see what happens. Okay, so this was a bit stupid on my part, so you can just simply do the .-all-run, ./all-run, and then it will give it to you. So now you can see what it's doing is it's doing service features, block mesh, decomposing them so that it will be able to run in parallel. Now it's running the snappy hex mesh. This will probably take the longest out of anything. As I was talking earlier, it took me 20 minutes. Most of the time is actually spent running this. It's insane that this takes the longest. I don't really know why. It also sort of depends on how fine of a mesh you want. And as I was talking, or as I showed in those F1 earlier, some of those elements are really thin, so it can be quite small. But I suggest that if you're curious on just seeing how your computer's performing, or if your computer can handle it, or whatever, then you can run it and see what happens. For reference, the clock says it's 10:30 right now. So I'll probably stop the video, and then I'll come back when it's done, and then I'll give you guys an update on how long it took for me, and you can compare your hardware against mine. And this is just doing the all run file, so it should be standard if you didn't make any changes. Yeah, so we'll come back in a few minutes when it's done, and then we'll just have fun looking at the results, and then I think we'll end the video. Okay, so I'm back. It was 5 minutes. This was actually much faster than the F1 simulation we'll do later, mostly because there's less cells. But okay, if you know your computer's worse than mine, you can also probably go into the system folder, like I said, go to the control dict, and change the end time to, let's say, 100, and the write interval to, let's say, 20. Change that, and it will run much faster. I'm going to not save this, but if you want to save some time, you can probably also do that. And let's play around a bit with the simulation results. I'll also show this a little bit later in my data analysis results. You can view the results of your simulation simply by typing Parafoam. This is some collaboration between ParaView, the actual company, and then OpenFoam, the software we're using. Yeah, just type in Parafoam, and then it will open up ParaView in a OpenFoam very friendly way. So this is a lot of buttons. You only need to know a few of them, and that one is the apply button. So then we'll just get a big rectangle. This is our rectangular simulation I was talking about earlier. Now, of course, we're not really interested in all these air cells. In fact, we kind of just want to see past them. So what we're going to do is we're going to go to the left, and then we're going to go here and we see mesh parts. So as we mentioned, there was a lot of mesh parts. So front and back, inlet, internal mesh, and all these other ones. We don't really care about a lot of them, so we're just going to turn them off. Internal mesh, this will make all the air clear, but we still see the walls, so not really that useful. Turn off the front and back, the inlet. Maybe we'll keep the lower wall for fun. And then you just scroll all the way to the bottom for some other ones for the upper wall and the outlet. I think they're by alphabetical order. So click apply, we have to update it. And then we see, oh, there's a motorcycle. This is what we were simulating. So you can zoom in with the scroll wheel. And then you can move also by middle clicking the scroll wheel. Panning. Yeah, so this is it. And then you can drag also with the mouse. And this is our guy. Here you can really see that it's a grid. You can really see some of those. Right now it's just displaying all the colors of different parts. So you can see the rims are pink, the tires are green. Let's maybe change it to the pressure. So up here you can do some tools. So we'll click P for pressure. And now you can see it's all blue. Well, it's all blue because this is the initial time step. Nothing really been calculated, so we'll just go to the final time step. And there we see that there's some pressure differences. It's a little bit blocky, I don't know why. That's better. There's two P's. They do something different, but I don't know. You can see that, of course, there's a lot of high pressure right here, and low pressure, let's say, on the back. If you're into fluid mechanics, you can also see that actually the lowest is on the side. This is because the air speeds up there. But yeah, it's interesting. But yeah, that's all. I hope that in this video you've learned how to install OpenFoam and the powers of OpenFoam and getting ready for our first simulation. Next simulation, I'm going to show you how we can adapt this motorbike case to simulate a front wing of an F1 car, starting from downloading it by a Reddit thread actually, all the way to showing our results. So I hope to see you there, and if you found this useful, please leave a like. Thank you, and see you on the next one. Bye bye.